speed, distance travel per unit time, flow is number per unit time, density is the number of vehicle per unit length. Okay, so if you have 2 out of these 3, you manage to calculate to get the other one. Okay, so the relationship goes this way. Flow rate equal to speed multiplied by density. Flow rate is Q, speed is U, and density is K. If you look at to their unit, we know that the unit for speed is kilometer per hour. Then the unit for the density is vehicle per kilometer. So when we cancel out the kilometer, we get vehicle per hour. And this vehicle per hour is Q. Okay, so that is the first relationship. Q equal to UK. The second relationship between, ini between apa ni? Kalau kita tengok ni, antara apa dengan apa ni? Relationship antara
initial velocity.
Okay, velocity, the speed dengan
density.
Dengan density. Bagus. Sebab kat sini kalau kita tengok dia ada U kan, UF and K. Tak kisahlah K ke KJ, but it's K. KJ bukan Khairi Jamaluddin nanti saya cerita KJ ni apa. Okay, so the relationship between U and K, between speed, okay, tadi saya ada mention about U or V, tak kisah which one is initial, which one is final, doesn't matter as long as you know U is speed. Okay, so the second relationship is between speed and density. Kita move to the next slide. The relationship between U and K, kita tengok lebih detail. UK relationship. If you look at this graph, we know that it is linear relationship, but inversely proportional, kan? Inversely proportional, dia negatif, dia punya gradient dia negatif. Kalau positif dia akan bentuk macam ni, dia naik ke atas positif, which when the value of x-axis increase, the value of y-axis increase. That is positive relationship. But for the UK relationship, it is inversely proportional. Okay. We know that the linear relationship is standard y equal to mx plus c. Y is y-axis. So on the y-axis here, we have speed. So the y is u. Okay. Then m is the gradient of the graph. So kalau kita kira, kita akan dapat uf minus 0. Okay, the gradient of this graph over 0 minus kj. Betul tak? Nak dapat gradient.
Betul.
Betul.
Then x is the x-axis. So on the x-axis is the k. K lah, k vehicle per kilometer. So x tu adalah k plus c. C adalah dia punya y. Dia punya apa kita panggil apa ya? Pintasan y. Saya belajar matematik nak kan? Pintasan y tu kan. So it is uf. Rearrange the formula, then you can get this. U equal to, this is negative, kita bawa uf ke depan lah. Uf minus, sebab ni kan uf tolak kosong, over kosong tolak kj. So the negative uf over kj times by k. So that is how we derive the formula based on the graph and QUK relationship. Okay, that is the formula, UK. Now, let us look into the graph. From the graph, we know that y-axis is U and the unit is kilometer per hour, while x-axis is K in unit vehicle per kilometer. Okay. The first symbol, stable flow, solid line. So where is the stable flow? From the UF until the midpoint here. The solid line here indicates stable flow, while the dotted line here, starting from the center line till Kj here, that is unstable flow. Okay, dotted line, unstable flow. Then we have Kj. Kj is located at here, the maximum point of the K. And it is jam density where there is no movement. Kenapa no movement? Dia dekat sini, kan? Point dia dekat sini. Kalau awak tengok, at this point, the speed is equal to 0. So maknanya dia dah jam, bumper to bumper, tak bergerak. Okay, so that is jam density. Then we have UF. UF is free flow speed. So the location of the UF is here at the highest point. Okay, maksudnya bila tak ada kenderaan ataupun satu kenderaan sahaja atas jalan, dia boleh bawa selaju mana dia nak. Asalkan jalan tu selamat lah. So that is called as free flow speed. Okay, then we have UC here. UC equal to UF over 2. So UF is here over 2. Maksudnya UC divide the distance here equally. Let's say the UC is 50, so UF equal to 100. Because the distance between half under unstable flow to the half under stable flow is the same, sama. Okay, UC ni apa? Dah bahagi dua, tapi UC apa? UC is speed at capacity. C stand for the capacity. So in the middle is the capacity. Same goes to the K, KC. KC is the K at capacity. The density at capacity. So the density at capacity equal to Kj over 2, which the jam density divided by 2. Again, the distance from 0 to Kc and Kc to Kj are the same. Sama. Jarak dia sama. Okay. For example, Kc is 100. So Kj is 200. Sampai situ boleh dapat?
Clear, Doktor.
Clear?
Ya, doktor.
So now, x-axis is the number of vehicle per kilometer. Y-axis is speed. Okay. When the number of vehicle increase, maksudnya K bertambah. Di atas jalan 1 kilometer K bertambah ke kanan. Awak tengok cursor saya, nampak kan saya punya mouse ni? When the K increase, when the number of vehicle increase, what will happen to the speed? Speed will decrease.
Inversely proportional.
Yes. So the speed will decrease until it reach the capacity at the midpoint here. But when the number of vehicle keep increasing, exceed the capacity of the road, what will happen? It will approaching to unstable flow, dotted line, until jam occurred. Okay, dah congested, tak bergerak. So when the number of vehicle increase, the speed will reduce until it capacity, but if the number of vehicle keep increasing, the speed will start to drop until no movement at all. Jam density, speed drop to 0, static condition. Boleh dapat relationship dia? Boleh bayang je kan, bila banyak kereta atas jalan tu lama-lama kalau dia seorang je makin laju, dia laju je. Bila ada kereta lagi yang kedua, ketiga, keempat dan seterusnya, speed tu semakin berkurang sebab dia mula ada obstruction by other vehicles, dia mula follow, patterning, so semua tu akan affect dia punya speed. Okay, that is the second relationship between U and K. Okay, now we move to third relationship between Q and Q dengan apa ni? Density. Betul, sebab kita ada U juga, kita ada K, tapi the highest degree is K kan, dia ada 2 kat sini. So dia adalah relationship between Q and K. So how to derive or how to get the third equation ni? So senang je. Yang equation 2 ni awak multiply by K. All of it, multiply by K. We know that when you multiply by K, we will get Q, kan? Because Q equal to UK.
UK.
So UF multiply by K, then we get K UF. Then this one multiply by K, tu yang jadi K square. Okay, so that is how to derive or to get the third equation. So kita tengok lebih detail about this QK relationship dekat slide yang ni. Okay, this is the formula. On top ni, dia punya formula Q equal to K multiply by UF minus UF over KJ. Okay, minus kenapa? Sebab graf ni quadratic kan? Quadratic masam. Kita ada yang positif quadratic tu kalau dia senyum kan? So kalau dia masam maknanya dia negatif lah. So the negative relationship UF over KJ times K square. Okay. Sebelum saya pergi penceritaan dia macam mana, kita tengok simbol dulu. On the y-axis is Q, vehicle per hour. On the x-axis is density in vehicle per kilometer. Then we have one value of Q, here Q1. Kalau kita tengok relationship dia, Q akan ada 2K sebab K square kat sini. Jadi, one value of Q will give you two value of K at A and at B. So, tarik ke bawah, we have K1 and K2, which K1 is the density under stable flow, solid line ni. While the K2 is the density under unstable condition. Okay, unstable condition, dotted line ni. Lagi apa? Lagi, from the center line to the point A and point B, because the polygon, the graph is symmetry. So the distance from the center line to point A and the distance from the center line to the point B are the same. X sama. Kalau sini 100, X equal to 100, yang ni pun 100 juga. So dia symmetry. What else? We have UA and UB. U is the speed, means the gradient of the graph is represent speed, UA and UB. So UA kalau awak tengok dia punya kecerunan, dia punya gradient lebih tajam, lebih steep kan as compared to UB. So maksudnya UA lebih laju daripada UB because UA is under stable condition while UB under unstable condition. Okay, KC. KC is KJ over 2. Okay, it divide the polygon into 2. Okay, to equal distance. Okay, so for example, KC is 100, so KJ is 200. Okay, lagi kita ada lagi kat sini QC. QC is the maximum theoretical flow. QC equal to KJ times UF over 4. So macam mana dapat KJ dengan UF ni? Sebab dia bagi 4 kan? This is actually to get KJ. KJ adalah okay. Because at QC, so the K must be at KC, the U must be at UC. Okay, so QC, when the Q at their capacity, the K must be at capacity, U must be at capacity. So KC equal to KJ over 2, while UC equal to UF over 2. Sebab tu dia dapat formula KJ UF over 4. Itu macam mana nak dapat QC ni lah. Okay. Sampai sini ada soalan lagi tak?
Madam, yang UB tu, UB tu, gradientnya mana satu Sebab UA yang hitam line full ni, yang UB ni gradient dia.
UB ni. Yang ni. Garisan ni. Nampak ke mouse saya?
Yang dotted line tu Oh, itu.
Daripada 0 sampai B.
Kenapa dia?
Tapi kita tak kira pun U dekat sini, tak apa. Sebab dalam formula, Dalam formula kita tak ada U pun. Kita ada UF sahaja, which the free flow speed. Okay. Saya cerita dia punya relationship dia. Okay, we know K density is the number of vehicle per kilometer. Jumlah kenderaan di dalam 1 kilometer jalan. While flow is number of vehicle per hour. Okay. Kalau x-axis bertambah, maksudnya when the number of vehicle increase on the road, apa akan jadi pada flow? Flow will increase. Logik tak? Okay. Awak bayangkan jalan kosong, ada satu kereta. Okay, ada flow. Ada dua kereta, so flow bertambah. Ada dua flow. Ada dua kereta. Ada tiga lagi. Okay, ada tiga pula. So, number of flow to increase from 1 to 3 until it reach the capacity. Katalah capacity is 500 vehicles per hour. Okay, 500 vehicle per hour. So, when the number of vehicle increase, the flow will increase until it reach the capacity. So what is the capacity? Capacity is the number, the maximum number of the vehicles that the road can accommodate or withstand or cater under design level of service or design performance. Katalah jalan tu di design untuk level of service C. So at level of service C, the maximum capacity is berapa? Katalah 500. So that is the maximum theoretical flow. But when the number of vehicle keep increasing, maksudnya dia dah melepasi KC ni, dia tambah lagi. Dia boleh tambah lagi. So what will happen to the flow? The flow start to drop. Flow menurun. Maksudnya aliran kenderaan, flow ni kita boleh bayangkan dia sebagai movement, pergerakan. Bila lagi banyak kereta, apa jadi dengan gerakan kenderaan tu, dia makin perlahan. Betul tak? Bila banyak lagi kereta, dia jadi slow, lama-lama dia akan jam. Kan? Betul kan?
Betul.
So, when the number of vehicle keep increasing, the flow start to drop until it reach the jam density. Maksudnya bila jam density ni dah tak ada pergerakan, sebab itulah kalau kita tengok kalau U is the gradient kan. Gradient dia ni dah flat dah, kosong, tak ada apa dah. Okay, so U dah kosong, dia dah jam, flow pun kosong. Maksudnya tiada pergerakan, no movement at all. That is when jam occurred or congested. Okay, traffic congested. So when the number of vehicle increase, the flow will increase until it reach the capacity. But when the number of vehicle exceed the capacity, what will happen to the flow? The flow start to drop until stop condition, KJ. Okay, saya bagi satu example yang lagi senang awak nak nampak. Mungkin bila kereta ni tak nampak lah macam mana ni. Okay. Awak bayangkan awak ada gelas. Satu gelas dia punya capacity katalah 500 jugalah, 500 ml. Okay, tengah-tengah puasa ni pagi-pagi buta cerita pasal air sirap tau. Ni gelas air sirap. Okay, ya Allah, astagfirullahaladzim. Okay, satu gelas 500 ml. Awak ada satu botol 1.5 liter, botol besar. Okay. Gelas tadi kosong, 500 ml. Awak tuang air yang 1.5 liter botol tu ke dalam gelas. Tadi gelas tu kosong. Gelas bila awak masukkan air, air akan bertambah. Maksudnya flow dia meningkat, air bertambah, capacity dia bertambah. Sampai awak tuang until it reach the capacity which is 500 ml. Maksudnya gelas tu dah penuh, dah sampai di capacity 500 ml. Tapi ada lagi air, air ni ada banyak lagi ni, nak tuang lagi, tuang juga, tuang. Bila awak tuang apa jadi? Bila dia dah sampai maksimum?
Overflow.
Jadi air tu tumpah. So samalah macam ni, jadi dia turun. Awak bayang dia melimpah lah, dia pun turun. Sebab dia dah sampai capacity, dia tak boleh lebih dah capacity. Dia takkan naik dah, dia akan turun. Macam air tadi cawan tu 500, so dia dah sampai capacity, dia pun tumpah walaupun awak tambah. Okay, air tu awak bayangkan itu adalah kereta, awak tambah lagi, dia akan turun. Sampailah nanti botol tu pun dah habis. So dah tak ada dah apa yang keluar dah. Berhentilah di situ. Macam tu. Boleh dapat ke?
Boleh.
Boleh.
Good. Okay,
Boleh,
we
doktor.
okay, good. So kita teruskan. to the last relationship between Q and U. Sebab U ni ada 2 degree kan, the highest degree. But you can try to derive this equation. Kita kena buat differential. Kita kena buat differential. Okay, cubalah awak cuba buat, nanti kita cuba share. Okay, kita kena buat differential untuk dapatkan this formula. Okay, tapi kita tengok relationship dia macam mana. Relationship dia goes this way. Okay, this is the formula between Q and U. Quadratic juga tetapi berbentuk ellipse. Ellipse ni. Kita panggil ellipse ke parabolik? Parabolik kot. Okay, ellipse. Sama je lah kot. So, for this relationship, kita tengok dulu simbol-simbol yang ada. Dia ada QC juga, which is the maximum theoretical flow. Dia ada 2 types of line, which solid line, and also dotted line, which solid line represent stable condition, dotted line represent unstable condition because it is a quadratic relationship. One value of Q will give 2 value of U. Therefore, at Q1 here, at Q1, kita ada U2 and U1. Dia ada 2 value of U. U under stable condition, U under unstable condition with the same equal distance. Okay, contoh kalau sini 50 dan yang ni pun 50 sebab dia divide the polygon into 2. Okay, at the KC, which at the maximum theoretical flow, the U here is UC. UC is the U at capacity. So, U at capacity equal to free flow speed divided by 2. Maksudnya, the distance from UF to UC equal from UC to 0. Okay, so dia divide sama. Okay. Sampai situ boleh ke?
Boleh.
Okay,
Boleh.
So, kita tengok dia punya relationship. Dia macam, yang ni dia dah kompleks sikit tapi hopefully awak boleh bayangkan Awak bayangkan. Okay, axis, X axis is flow, vehicle per hour. When you move to the right, that means the flow increase. When the flow increase, speed will reduce. Sebab awak bayangkan ada satu kereta, dia boleh achieve the free flow speed. Bila ada 2 kereta, dia start to slow down. 3 sampai 50, 100, jadi speed semakin berkurang. Speed will reduce when the number of flow increase until it reach the capacity. Dah sampai capacity, the U is at U capacity. Flow dah tak boleh melebihi dah. Flow dah tak boleh melebihi maximum theoretical flow. But flow, when the number of vehicle keep increasing, which the number of density increase, kan? Density increase. Apa jadi pada flow? Flow akan drop. Kan? Graf yang sebelum ni, flow drop. So, dia patah balik. Bila dia patah balik, speed apa jadi? Speed akan tetap turun. Makin turun, makin turun, makin turun sampailah ke stop condition where the speed equal to 0. Boleh tak dapat the relationship? Boleh bayang
Boleh.
Okay, good. So that is the relationship between Q and U. Let us try this example. Okay, cuba buat, saya bagi 5 minit. Sekarang 9.15, 9.20 nanti saya panggil random siapa-siapa. Okay. Traffic volume during a stable free flowing condition is 600. So this is Q. Average speed 75. Estimate the average speed of traffic under congested situation for the same volume of traffic if speed and flow are related. So it is UQ relationship. Maximum free flow speed is 90 km per hour. Okay, cuba kira. 9.20 saya masuk balik. Okay, dah dapat ke jawapan? Kita try. Saya nak panggil siapa kita panggil Saifuddin. Saifuddin, berapa jawapan awak?
Jawapan untuk U2 madam.
U2.
15 km per hour.
15 km per hour. Okay, Saifuddin tolong share awak punya calculation dalam WhatsApp group boleh? Supaya kawan-kawan boleh tengok. Ada yang dapat jawapan lain daripada 15 km per hour tak?
Sama.
Sama, okay. Saifuddin tunjuk cara awak kira sebab there are two types of calculation. Ada dua method nak kira.
Baik madam. Tapi saya punya calculation pendek madam. Saya 90 ni saya tolak dengan 75.
Tak apa, share dulu.
Okey madam.
Ada guna cara lain tak nak kira? Ada tak siapa-siapa guna cara lain? Sekejap kita tengok jawapan Saifuddin. Okay, because this is a speed flow relationship. Okay, yang ni saya just nak bagi alternatif lah. Okay, alternative solution. Okay, saya rasa yang Saifuddin calculation pun sama macam yang kita akan tunjukkan ni lah. Okay, tak apa, kita pergi dulu. Sebab tak rapat pun lagi ni Saifuddin, tak share pun lagi dalam group. Okay, first you have to sketch the parabolic curve for QU relationship. Speed and flow are related kan? So ini adalah graph dia. Okay, once you sketch the graph, you can labelkan dia supaya awak nampak. Okay, ini QC, ini Q1. So Q1 ni lah 600. Okay, Q1 ni 600 because QU relationship ni one value of Q will give you two value of U. U1 and U2 kan. So at Q1 akan ada U1 and U2. So UF ni kita tahu 90 given 90. So okay, 90. Even you can calculate as well the UC. UC ni 45 lah, 90 bagi 2 kan. Dan kita tahu pun U1 given 75. Okay, if I'm not mistaken, Saifuddin kira 90 tolak 75. Sebab the distance between UF to U1 equal to U2 to 0. Kan? Jadi, boleh directly get U2 90 minus 75 equal to 15 km per hour. Sekejap saya tengok jawapan dia. Betul. Jawapan betul cuma tak sketch. Okay. Better sketch. Bila awak sketch, awak akan lebih nampak dan tak confuse kat mana position dia. Bila awak sketch macam ni, awak dah nampak. Kan? Yang ni lah 90 tolak 75. Dapat 15 km per hour. There is another option which you can calculate using formula. Which formula? QU relationship. Kita pergi kejap supaya nantilah macam kalau awak tengok past year ataupun manalah tahu nanti dalam test ke kan. Want to keep your ink notation? Okay, kita keep dulu. Nanti okay, kita try kat sini kosong. Kita boleh pakai QU relationship. We know that Q equal to U times by KJ minus KJ over UF times by U square. Okay, tolong tekan calculator. Nazirul boleh? Nazirul tolong tekan boleh? We know that Q is 600. Okay, satu je U yang diberi pada awalnya 75. Sebab apa? Sebab KJ kita tak tahu. So we have to determine KJ. Okay, so KJ ni kita kena dapatkan. We know that UF equal to 90. U kita pakai U1 dulu 75. So berapa KJ? Dapat berapa KJ? Yang lain pun boleh tolong kira rearrange 48. The formula 48. So 48 vehicle per kilometer. Okay, now
Doktor,
is it? Yes.
75 square.
Oh yeah, sorry, 75
Okay,
square. Tadi
48.
dah 75. Okay, 48. Then replace KJ into the formula, let the U as unknown variable. Jadi jadikan dia 600 equal to U times 48 KJ 48 over 90 times by U squared. Awak pakai calculator, awak boleh terus dapat U1 dapat berapa, U2 dapat berapa. Obviously U1 awak akan dapat 75, tekan je calculator awak dapat U2. Alah, mana entah calculator saya. Alamak. Awak pakai quadratic punya formula, pakai calculator, tahu kan? Tahu kan nak pakai calculator?
1 dapat 15.
Kan boleh dapat kan? Ada tak reti pakai calculator? Siapa boleh explain? Tekan apa? Calculator lain-lain kan orang.
Tekan mod, tekan 5, tekan 3.
Mod 5, 3. So dia bagi apa, kita kena masuk value
Berarti equation punya
quadratic equation. Betul? Terus dapatkan jawapan. Directly you can get 15 km/h. So there are two method of solution. Satu pakai yang tadi graph, satu pakai formula. Okay.